AP Cram, Calculus AB, Free Response Exam Review, Question 2, Water Flow Rate Through a Pipe. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t is equivalent to 20 the sine of t squared over 35 cubic feet per hour. So here goes the representation of our pipe, water entering the pipe, and water exiting the pipe, okay? T is measured in hours, and T is either greater than or equal to 0 hours or less than or equal to 8 hours. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by dt equals negative 0.4 t cubed plus 0.4 t squared plus 0.96 t cubic feet per hour, or t is between 0 hours and 8 hours, okay? So saying t is greater than or equal to 0 hours or less than or equal to 8 hours is the same thing as saying the time, or t, falls between 0 and 8 hours. So d of t represents the rate of water flow out. R of t represents the rate of water flow in, okay? There are 30 cubic feet of water in the pipe at time t equals 0. So pretend that this is a snapshot of time t equals 0. These molecules would represent 30 cubic feet of water, okay? The question that I want to pose to you is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? So give a reason for your answer, okay? So basically, in order to solve this problem, what one has to do is recognize that the rate of change of water into the pipe, that's represented by r of t, which is 20 sine of t squared over 35 cubic feet per hour, that is given by r of t minus d of t. So r of t represents the activity going in at this end of the spout. That's the rate of water flowing in, up, and d of t represents the activity going on at the end of the pipe, okay? That's the rate at which the water falls out. And they're not going to be exactly equivalent because you have the water molecules eddying and turning, then you have some slight blockage here, so the rates won't be exactly the same. That's why d of t is modeled by the equation negative, and it's negative because you're subtracting an amount of water, whereas r of t is positive because you're adding an amount of water to the pipe. D of t is negative 0.04 t to the third plus 0.4 t squared plus 0.96 t cubic feet per hour, okay? So we have to basically calculate r of t minus d of t. And you're expected to calculate this using your calculator. You're certainly, for the AP exam, that is. And even for an in-class exam, all you would do is plug in a 3 wherever you see a t. So that represents 3 hours. Plug in 3 here, plug in 3 here, plug in 3 there, and then you would get a negative answer, okay? So basically this answer, which is basically gotten by inputting these two equations into your calculator, is going to yield an answer of 0.313632 cubic feet per hour, which is less than 0, okay? So again, we input these two equations into our calculator, and all you do is write this equation out and then subtract this from it. Whereas the first term would be positive because minusing a negative is going to yield a positive. The second term is going to be negative, and the third term would be negative, okay? So since R of 3 is less than d of 3. This is another way you could look at it. The amount of water in the pipe is decreasing at time t equals 3 hours. For those of you who aren't calculator wizards and you feel more comfortable putting in r of t, evaluating it at 3, writing down your answer, and then evaluating d of t at 3 hours and then writing out the answer, then comparing them, this is an alternative way to do it, okay? All right, so again, you are expected to use your calculator to find out that the result is negative. Therefore, the amount of water in the pipe is decreasing, not increasing, at t equals 3 hours. Okay?